Welcome back. In previous video we discussed about candidate protocols, 4 different types of the candidate protocols, and this video will continue with the candidate protocols, that is protocol 5. So in the protocol 5, instead of using nouns, here you are using the timestamp, and this timestamp is you are denoted as a TB. TB indicates what? Timestamp generated by Bob and concatenated with the message, it's Bob, are you okay? And whenever it is received by the allies will send the message, generates the message authentication code for this message, what are the request it is sent by the Bob, with the help of the symmetric key here. So now here protocol assumptions are what? Here you are using the Bob will generate the and verify the integrity protected timestamp instead of source randomness here. So earlier in protocol 1, 2, 3, 4 we used randomness as a nouns. That one it is replaced by generating the timestamps and verifying the integrity protection with the help of this timestamp here. And protocol analysis, data origin authentication of allies reply. So S here in the reply message, what it contains? TB. So TB and Bob, it indicates what it is. S, this is the reply for the message, whatever it is sent by the allies here. And this MAC, message authentication code function and key, this is known by only allies and Bob, which is shared between allies and Bob here. So next is freshness of allies reply. Freshness is based on your timestamp. So here you are included timestamp. That one you are included in the reply message also. This indicates the freshness here. And assurance that allies reply corresponds to Bob request. So here it is, assurance is very simple. So what is that assurance? TB, the TB timestamp of the Bob and identification of the Bob as a Bob here. So this is the protocol 5 here. So you may have the doubt, that is, so all the 3 security goals are reached. Then what's the drawback of this protocol 5? So I'll explain what's the drawback here. For example, assume that attacker will continuously monitor the communications between allies and Bob here. So now assume that now time is, that is the timestamp is 10 here, and attacker will get to know that after 5 minutes Bob will send the message to allies here based on the browsing the communication of the allies and Bob here. So then what the attacker will do? Now time is 10. So but that attacker will know that after 5 minutes Bob will send a message to allies here. So then attackers will generate the request message. In that request message, attackers will add the time as 15. Actual time is 10 here, but the timestamp attacker will add as a 15 and it sends to allies. So whenever allies will receive that, it thinks that thinks that I am receiving the message by Bob here, but actually it is received the message by whom? It is received by the attacker here, but it is unknown by allies here. So that's why allies will send the reply. So that reply message contains what it is? Timestamp as a 15 and identification as a Bob, as I am okay. This identification is just name here. Okay, that name is even known by the identification of the attackers. Attackers will know the identification of Bob here. So that's why they that message is contain the Bob identification and the timestamp. Timestamp is what now? 15 here. And for that message authentication code is generated and it is sent to attacker here. Actually allies will think that I am sending the reply to Bob request, but it is actually reply for the attackers, and attacker will keep that message as it is. After 5 minutes, whenever Bob will send a request, that request once again attackers will keep, and now what are the message it is received by the allies? No, that reply message attacker simply forward to Bob here. So this is the problem of the protocol 5 here. So to overcome from this problem, protocol 6, instead of using the timestamp of the Bob, in this you are using the timestamp of allies here. Yes, here you are sending it's Bob, are you okay as a message. For that message, reply message contains what it is? Timestamp generated by whom? It is generated by allies, and identification of the Bob as I am okay message here. Okay. Next, message authentication code is generated for this message as a reply to Bob here. So protocol assumption for this one here, random generator is replaced by whom now? It is replaced by Bob and it is now generated by Alice here. Earlier Bob will generate the timestamp and now Alice will generate the timestamp. And what is the work of Bob? Bob simply verify the timestamp here. And protocol analysis, data origin authentication of Alice reply here. So data origin authentication for the Alice reply is here Alice reply. How we'll get that? This is the reply message. So here you are having the identification as a ID and it indicates what is this is the message or data origin of the message authentication of the Alice reply here. And freshness with the help of the timestamp TA here and assurance that Alice reply corresponds to Bob request. So how we'll get to know that this is the message is sent by Bob only, because there is no any other identification. Simply Bob is sending the message here, hello message. So now what are the message it is sent to the Alice? No. So that Alice message contains what it is. So there is the no identification of the Bob here. So but while sending the reply, that contains the Bob as a identification. So this is the assurance that Alice reply corresponds to Bob request only. So now also same problem arises. Only thing is what it is, instead of timestamp generated by Bob, here it is generated by Alice. Only that changes if you are done. It doesn't prevent from the attacker's problem here. So to overcome from that, protocol 7 is used in the protocol 7. So you are adding one more extra thing, that is IDS. This is the session identifier along with the message. And Alice will generate the timestamp and session identifier, Bob identification, yes I'm okay. And for this message authentication code is generated with the help of this key K here. Assumption, protocol assumptions are here. It is what? It is same assumption as protocol 6 here. So only extra thing you are included here is what? That is the unique session identifier in the request message. And synchronization here, one more thing is what it is? Alice and Bob have synchronized clocks by our assumption. So in protocol 6 and protocol 7, you are using the timestamps. For generating that timestamps, you require the synchronized clock. If you are having the synchronized clock only, then you can prevent from such type of the attacks here. So it is not strictly necessary that the data on which MAC is computed matches the reply text, so long as Bob receives all the critical data that he needs to check the MAC here. So now here MAC computation is also a little bit complex. To prevent from that, you can check the messages. For all the messages, it is not necessary to add the message authentication code here. Only critical data if it is there, for that critical data only, if you are make computation of the MAC, it is good here. Okay. So this is about regarding the candidate protocols. So as you know that you already learned 7 protocols. If you are study one by one, as all the protocols reach protocol 1, 2, 3, it reaches the security goals also. After reaching security goals also, you have faced some problem. So as you know that, okay, providing security goals is not a simple task here after studying this 7 protocols here. Yes, how much it is possible according to your requirement, it is possible, but it is not a simple task providing the security during communication. So that's why generating the crypto or designing the cryptography protocol is not a easy task. It is very hard here, because after studying 7 also you get to know that there is some problem even in protocol 6 and even in protocol 7 also. So that's why it is not a simple task to generating the or designing the cryptography protocols. Is it clear now? Okay, thank you.